So let's take a look at section 1.4. So this is going to be on solving linear equations again. But this time we're going to have two of them to solve because we're going to look at what's called absolute value. Does anybody remember the symbol that you use in math to represent absolute value? Okay, just gave you a hint. Yeah.
2 lines in between the number.
Yeah, so you get the two vertical lines. Okay, that means absolute value. So I don't think on your guided notes, nope, there's not a spot for that. But if you don't know that symbol, you might want to write down what it is. It's the two vertical lines. So again, just one for us to try together. You don't have to write this down. What if I wanted to write down the absolute value of 4? What would I write down on paper if I wanted someone to do that? Yeah?
Line 4 line.
Yeah, you put your vertical line, put your 4. Just make sure your lines don't look like 1s, so make sure they're definitely bigger than the number. Yep. So that's how you write the absolute value of 4. And what would the absolute value of 4 be? Yep.
4.
Yeah, it would be 4. Oops. Scrolled. And the reason that it would be 4 is because absolute value really measures something. If you think of like a number line. Here's 0. Here's 4. Does anybody know what absolute value measures?
Numbers?
Something about the number 4. It kind of measures its how. I can't really say it without telling you yet.
Positives?
Okay, the answer is always a positive. Yep. And does anybody know like what we're?
Opposites?
No, it's always positive. So it has to do with positive numbers. It really measures how far away you are from something.
0.
Yeah, that's what it measures. It measures the distance that a number is from 0. So that's why the absolute value of 4 is 4. Because if you measure the distance between 0 and 4, it's 1, 2, 3, 4. Now, is there any other number besides 4 that is also 4 units away from 0?
Negative.
Yeah, negative 4. Negative 4 is exactly the same distance away from 0 as positive 4. 1, 2, 3, 4. So if I asked you to find the absolute value of negative 4, what do you think you would say? Yeah?
Negative 4.
So remember, absolute value is measuring a distance. And what kind of number does distance always have to be?
Same distance away from 0.
So in general, like if you measure the distance, from one side of, your room to the other side, you're always going to get a number that's what?
Positive.
Yeah, positive. Okay, you're never going to get a negative number when you measure the distance. So if you want to try that one again, absolute value of negative 4?
4.
4, yep. So there are two different numbers in math that have an absolute value of 4. Positive 4 and negative 4. Because there's 2, when we solve equations, we're going to have to solve 2 equations. So on your guided notes, the part that's highlighted in yellow, the absolute value measures. You could really just write what's in yellow, distance from 0, or you could put the distance a number is from 0, if you want to kind of spell it out. Right, it's important to remember that absolute value is always a positive number. Let's see. So that part, no, you don't have to write that part down. But you might wonder, well, how do you know if something is an absolute value equation? Well, it has an absolute value in it, right? So if you had something like this, is that an absolute value equation? No, it doesn't have any absolute values in it.
It's not 2 lines. That's an absolute value.
That's an absolute value equation. Okay. So you're usually going to have something on the left between the two vertical bars, and then you're going to have a number on the right.
So whenever you have an absolute value equation, it's always going to be positive.
Where? The number on the right-hand side? Yeah, it would have to be positive, because if it wasn't, it would be a no solution. And we pretty much focus on ones that do have solutions. We'll see if we do one that's a no solution, but I don't think we do in this class. So these are the 3 different types of things that can happen. That's the most common one. I think that's the one that we pretty much focus on. But when you solve an absolute value equation, you could end up getting 2 answers to the problem. You could get 1 answer to the problem, or you could get no answers. But 2 is the most common, and that's mostly what we're going to focus on. Okay, so how do you solve an absolute value equation? Well, a lot of the steps are very similar to what we've learned about just solving regular equations. But there's a couple things we have to make sure we do first. So let me show you 2 different absolute value equations. Okay, so here's one. 2x plus 3 equals 5. And here's another one. 8 plus the absolute value of 3x minus 4 equals 7. One of these equations has the absolute value by itself on the left-hand side. The other one doesn't. Does anybody think they know which one has the absolute value by itself on one side? Yeah? The top one. Okay, when we're talking about having the absolute value by itself, what you can basically do is think of it like this. Don't even look at what's inside here. It doesn't matter. All you're focusing on is what's on the left side. Is there anything outside the vertical bars? If there's something outside the bars, then the absolute value is not by itself. Okay? In order to solve an absolute value equation, that's the first thing we need to make sure of. We have to make sure that the absolute value is by itself, like the top one. Okay? So let's write that down. So we have to ensure that the absolute value expression is by itself on one side of the equal sign. Now there's really 2 different ways that it might not be by itself. One way is you have a number that's multiplied on the outside of the absolute value. Another way is you have a number that's added on the outside of the absolute value. It could be added or it could be subtracted here. But the point is you've got something on the outside of the absolute value. So you're usually multiplying or adding. Yeah.
Can you solve the problem when you have something on the outside of the absolute value?
Yes, you can still solve it. We just have to make sure we take that number and move it to the other side first. Okay, and I'm going to show you an example. I'm not going to do those because those ones won't come out nice. But I'll show you what you do. Okay, so if there is a number attached to the absolute value, okay, like this one, right, or something like 3 absolute value 5x plus 6 equals 12. The 3 is attached to the absolute value. It's like it's right next to it. So if there is a number that's attached to the absolute value, when something is right next to it, it means it's being multiplied. What's the opposite of multiply? Divide. So the first thing you'd have to do in this problem, again, don't even focus on what's inside here. You can almost put like a box there and just ignore it for now. The first thing you'd have to do in this bottom one is divide each side by 3. And that would get rid of the 3 on the left. And then on the right, you'd have to do 12 divided by 3. Let's try that. This one's actually pretty similar. Let's try it with this one. Okay, we're not going to go through and solve the whole thing. All we're going to do is make sure we can get the absolute value by itself. Okay, that's always the first step. Okay, so let's look at this one. 3, absolute value 2x plus 5 equals 6. Is that absolute value by itself? What do you think, Heather? No. What's next to it that makes it not by itself?
3.
The 3. Okay, and that 3 is attached to the absolute value. It's right next to it. So what am I going to do on both sides to get rid of that 3? Yeah? Yeah, divide by 3. And again, just ignore, don't do anything to what's inside here. In fact, I just put a box there. You don't even need to know what's inside there to do this step. All right, so all we're going to do is divide by 3 and divide by 3. What happens on the left side when you do 3 divided by 3? Cancels out and you get
0. Or
1. Yep, you divide two things that are the same. They cancel out. And what do you get on the right side? What's 6 divided by 3?
2.
2. Okay, now I need to know what's under that box because I need to write that on the left side. Okay, but I didn't do anything at all to what was inside those bars. It's still 2x plus 5. And that would be your first step to solving this problem. Okay, we just get rid of the 3 by dividing by it. Now, if your problem started with this, that's even better. Then there's nothing you have to do at all to get the absolute value by itself. So sometimes it'll already be by itself, like in example 1a. Sometimes probably have an example where it's not somewhere. Like that one, example 2a, it's not by itself. Okay, so that's that one. Now, the other case you can have is if you have a number added or subtracted to the absolute value. Okay, that's still something we have to fix first because we've got to get the absolute value bars alone. Okay, don't do anything to what's inside. You're just worrying about stuff outside the bars. Okay, so if, let me scroll down a little bit. So now let's take a look at what happens if we also have something that's added or subtracted. Okay, so now we've got both things. So if there is a number attached, that's what we just dealt with, and there is also a number that's added or subtracted. We're going to have to do the opposite operation on both sides. So that means if you have like a plus 3, you're going to have to do a minus 3. If you see a plus 8, you're going to have to do a minus 8. Okay, you're going to do the opposite operation on both sides. So I'll put here, that'll either be add or subtract. So when I say opposite operation, I would have put it in parentheses. If you have space, you can squeeze it in right after the word operation. That would be good. So it'll be either add or subtract. You do that first. Then you do what we just learned. Divide by the number that's attached. All right, so this would be the case where you've got two things outside the absolute value bars. Something like that. Okay, so again, sometimes what I do, just to make sure I don't mess up what's inside the bars at all, draw, right? You can pretend like there's a box there. You're not going to do anything to what's under that box. All you're going to do is look at the numbers that are outside. Okay. So in this case, do we have a number attached to the absolute value and a number that's been added or subtracted? Yeah, we've got both. So it says the first thing to do is to do either the opposite operation, which is the adding or subtracting. It's really just like Sam, right? You always do the adding or subtracting first, and then you do the multiplying and dividing last. Okay? So is there any adding or subtracting that we could do to get those bars by themselves? Sam?
I'm sorry, I had 14 on both sides of the equal sign.
Yep, we're going to start by adding 14 on both sides. Okay, so we're doing the opposite operation. We had subtraction, we're doing addition on both sides. And what happens when you do negative 14 plus 14?
Cancels out.
That cancels out. Now on the left side, what do we still have on the left side?
6.
Yep, we still have the 6. We still have the absolute value bars. What's inside the bars?
A and then negative 7.
Yep. I just need a little bit more space. So we have the 6, the A minus 7. Nothing happened to that. And now what's on the right side?
24.
24. Okay, so that's a little bit better. But do we have the absolute value by itself?
No.
No, we still don't. Now we have a number attached. And that's what we learned how to do right before this problem. How do we deal with that number that's attached?
We divide it on both sides.
Yep. And what do you divide both sides by?
6.
6. And remember, think of those bars as like protecting everything that's inside them. Just don't do anything to what's inside the bars. So 6 divided by 6. What's going to happen there?
Cancel out because you get 1.
That cancels out because you get 1. And what's on the left-hand side now?
Yeah, absolute.
The absolute value
A minus 7.
of A minus 7. And that was the whole goal, okay? We had to get that absolute value by itself. And then 24 divided by 6
4.
is 4. Now, we haven't solved it for A. We have to figure out what A is. But now we're ready to do that because we isolated the absolute value. We got it by itself. Okay. Yeah.
Wait, now when we divide the negative 7 by 4?
I'm going to show you what you do now.
Okay.
Okay, so step 2. Okay, so on your guided notes, we're right below where we just did the plus 14 and the divide by 6. Step 2, that is to eliminate the absolute value bars. Okay, so now we're going to get rid of them. Okay, the way we get rid of the bars is we have to take the problem and we have to split it into 2. We're going to take the original problem and we're going to split it into 2 problems. And the reason we have to split it into 2, we talked about that earlier. When you take absolute value, there are 2 numbers that would have the same absolute value. We did an example of 4. 4 has an absolute value of 4. Negative 4 has an absolute value of 4. Yeah.
So is that why it's so common to get 2 answers?
Yep, that's why we get the 2 answers, exactly. Now remember, you can't do that until the absolute value is by itself. So you have to make sure you do that step first. Okay, so what are going to be your 2 different equations? Let me make one up I don't think you have one filled in. Actually, let's just do the one we already kind of started. Absolute value of a minus 7 equals 4. A minus 7 equals 4. Okay, so it started out with that minus 14 and divided by 6. We fixed that, so we didn't have the minus 14 anymore. Then we fixed the 6. And now we're ready to split this into 2 problems. And it pretty much says on your guided notes, actually no, I don't think it says it, right below the 2 vertical bars. You probably want to write this in. Written with no, and then absolute value bars. On the left arrow, you can put the word original. I don't think you have that on your guided notes. So we're going to put original. So one of the equations that we write down is going to be exactly the same as the original. We're just going to write it with no bars. We're literally just going to erase the bars from the problem and then write it down. So what do you think you would write here for your first equation? If all you do is just take the bars in the original problem, get rid of them, but keep everything else the same. Yeah?
A minus 7 equals 4.
A minus 7 equals 4. We'll come back to that, but that's going to be the first equation we solve. Now, the second equation we have to solve, it says we have to do one more thing. We're still going to write the problem without the bars, but we're going to make the number after the equal sign a negative. And that's going to give us the other answer. Anyone think they could tell me what that second equation is going to be? So still get rid of the bars, but make the number on the other side a negative. Yeah?
A minus 7 equals negative 4.
Yep. And those are the 2 equations that we have to solve. What's nice about solving them is the steps are the same. Right? Whatever you do to solve this one, like if you have to add something on both sides, it's going to be exactly the same step to solve that one. It's not going to be the same answer, but it will be the same step. So let's do it. What would you do on both sides here to get A by itself?
Add 7.
Yep. Add 7. Add 7. Negative 7 plus 7 gives me
0.
0. That's gone. We get 11. So that's your first answer. And then it says on your guided notes, answers are connected with the word and. I don't think I put that on the board, but you already have it on your notes. So A equals 11. And the other answer we get.
A equals negative 1.
So how did you solve this one? What did you do on both sides?
You said you remember after it's negative.
Yep, we did that. So we made the 4 a negative 4. Now we have to solve this equation.
Oh, I see.
So how would you solve this one?
You would add 7.
Yeah, it's the same step. I'm actually going to write that down in a
I
second.
think it was 3.
So negative 7 plus 7 gives you
0.
0. And we have A equals, what's negative 4 plus 7?
3.
3. Let's try it, see if it works. Let's plug in 11. What's 11 minus 7? 4. And what's the absolute value of 4?
4.
4. That's what we did earlier. Let's try 3. What's 3 minus 7?
Negative 4.
Negative 4. And what's the absolute value of negative 4?
4.
4. So we just checked both those answers and they work. So there's 2 different numbers you can plug in. All right. So the equations that you usually set up after you get absolute value by itself are pretty simple to solve. They usually don't have complicated like terms and things, distributed property. They don't have that. Okay, so the last thing under step 3, the steps are the same in both equations. We added 7 on both sides for the original. We added 7 on both sides for the other one. Okay. You do exactly the same steps, and you almost always get 2 answers. Okay, this part you guys already have written down below the asterisk. It's printed on your guided notes. It says answers are connected with the word and. So A equals 11 and A equals 3. Okay, so now we just got some different examples. We kind of did one together. I wasn't planning on doing that whole thing, but we did it. So I'll let you guys try example 1A on your own. Okay. Anything else here people need to copy down? Okay, so remember that you might not always have to get the absolute value by itself. Okay, look at this one. Is there anything you need to do to get the absolute value by itself? No, it already is. So you're ready to take this problem and split it into 2 problems right away. So take a minute or 2, okay, try that, and see if you can get the 2 answers. And when you do, I'll come and okay, so the first equation you write down is the same as the original, but you take away the bars. So what's the first equation that we're going to solve? Yep.
X plus 1 equals 3.
Yep, we're going to write down x plus 1 equals 3. Okay. And now the second equation we write down, we have to take out the bars. We also make the number on the other side negative. Yep.
The x plus 1 equals negative 3.
Yes. Okay, so those are the 2 equations that you set up. And to get x by itself, it's the same step in both. What would you do to get x by itself in the first equation? Yeah.
Subtract 1 from both sides.
Yeah, you're going to subtract 1 from both sides. Positive 1 minus 1 is 0. And we get x equals 2. 3 minus 1 gives us 2. Okay, and now we write our second answer. How are we going to get x by itself in the second equation? Sam?
You write. Oh wait, you already have the equation. You subtract 1 from both sides.
Yep. I'm going to subtract the 1 from both sides. So plus 1 minus 1 is going to cancel out. And then we have negative 3 minus 1. And what does that give us?
Negative 2. Negative 2.
So negative 3 plus 1 would be negative 2.
It's -4.
Negative 3 minus 1 is negative 4. Remember, when you have a negative number and you subtract something, it's going to go further to the left. When you add something, it's going to push the number further to the right. And that's it. Those are your 2 answers. Any questions on that? Oh, let's try. I think I got another one that's pretty similar. Oh, we didn't graph it. All right, so graph it. So what you have to do to graph it, okay, the number line will already be set up for you on Edge Elastic.
Just label it.
So yeah, let's just label it. Yeah, I mean, you don't have to label every number. That's good enough. As long as you have a spot to put those 2 answers. And what's the first answer we got? 2. So what we're going to do is we're going to put a dot on 2. That's how you graph that answer. And then what's the second answer? Negative 4. So when you graph your answers, all you have to do is put 2 dots on the numbers that are the answer. And that's it. All right, let's try this one. Okay, is the absolute value already by itself?
Yes.
Yes, then you don't have to do anything to get it by itself. You're ready to split it into 2 problems. So take a couple minutes, try that one, and then I'll check your answer. All right, let's take a look at this one. So again, absolute value was by itself. What was the first equation that people split this one up into to get rid of the bars? Yep.
There's 2x plus 4 equals 8.
Perfect. 2x plus 4 equals 8. And what was the second equation?
2x plus 4 equals negative
2x plus 4 equals negative 8. Yep. And now you solve each one of those, just like we learned how to solve equations earlier this week and last week. Okay, so we follow Sam on each one of them. So there's no combined like terms, there's no distributive property. You usually don't have those two steps in these problems. Is there any adding or subtracting? That's the A part of Sam. Yep.
Subtract 4 by 4.
Yep.
Do it on both sides.
So we're going to do it on both sides. It's going to be exactly the same step on the other one. So we subtract 4 from both sides. 4 minus 4 cancels out. And Marie, what's on the left-hand side now?
2x.
2x. And the right side, 8 minus 4 gives me 4. Now, we're done with adding and subtracting. Any multiplying or dividing that we can do? Yeah.
Dividing.
Yep, we can divide. And does anyone else see what we have to divide each side by? 2. So divide each side by 2. 2 divided by 2 cancels out because you get
0. Or 1x.
1. So we get 1x. And then 4 divided by 2? 2. So we get x equals 2. And now we solve the other one with the exact same steps. So start by minusing 4 from both sides. That leaves you with 2x on the left. Now be careful on the right. What's negative 8 minus 4? Sam?
Negative 12.
Negative 12. And then we still have to get rid of the 2 in front of the x, just like we did in the other one. So we're going to
Divide by 2,
divide by 2,
and it would become negative 6.
and we get x equals negative 6. Yep, perfect. Yes?
So from, since you added, so 4 plus 4, oh, I really thought 4 plus 4 was, so the 2x plus 4, I really think that the like terms, I really thought it was positive. I was like, wait, why? How did you get a negative there? And I realized, oh,
Yeah, this is a negative, minus 4, yeah.
The line of the positive.
Yeah. Now when we graph it, we just have to set up our number line. I'm going to count by 2s this time, just so I don't have to write as many numbers. So I'm going to do like negative 6, negative 4, negative 2, 0, 2. Okay, you're not going to have to worry about setting that up on Edge Elastic. That'll be done. Okay, and where's the first spot where we need to put a dot? Yeah?
Positive 2.
Positive 2. So that's an answer. And
Negative 6.
negative 6. And that's how you graph it. Okay. Question on that? All right. I just kind of want to see. So we got one where that's not by itself, and then we got another one that's not by itself. Okay, I want to make sure we do the not by themselves, but I think we'll have enough time. Let's try that one. So that's another one where we got the absolute value bars, and they're already alone. It's going to be a little easier than the last one because there's less stuff inside the bars. All right, so take a minute and see if you can do that. Checked in with, most people seem to do really, really good on this one. So the two equations, we split it up into, what was the first one?
3x equals 4.
And the second one.
3x.
3x equals negative.
And this one is a one-step problem. You just do one thing, and it's the same thing in both. How do you get x by itself?
Just divide.
Divide by 3.
Yep. Divide by 3 in that one and that one. Okay, so the 3's cancel, and 21 divided by 3 gives us 7. Okay, same idea on the left here. 3's cancel, and we get x equals -7. Now, as far as graphing, it could be a little tricky if it was a decimal. So the worst case, it might come out to like a 0.5. So then you go halfway between the two lines. But you're not going to have to graph something like 7.26 or something like that. You can't really do that on the computer easily. So -7 and 7. So what I would do with my number line this time, I would just put 0, 7, -7. As long as you count by 7. So like if I was going to keep going, it would be 7, 14, 21. But those are all I'm going to number. And then put your 2 dots. -7, 7. In Elastic, the way you do that is there will be a tool that has a dot. You click it, and then you'll be able to click on the number line, and you'll drag that point wherever you want to put it. And then if you need to put a second one, you can click and do a second one. Okay, any question on that one? Okay, so those all have the absolute value by themselves. And the last thing we'll look at is trying one where it doesn't. Okay, so why is the absolute value not by itself here? Can somebody tell me what the problem is?
The 2.
Yeah, we have a 2 that's attached to the absolute value. So let's just do this step together. How are we going to get rid of a number that's directly attached to that absolute value? It's like 2 times that absolute value. Yep.
Divide.
Yeah. And what are we going to divide each side by?
2.
2. So divide by 2. Divide by 2. And what happens when you have a 2 in the top and then a 2 in the bottom?
Cancel.
They cancel. Okay, so what's on the left side now?
3y plus 1.
Like that? We lost something. The bars, right? Yeah, bars are still there. Haven't gotten rid of those yet. We don't get rid of those till we split it. So the absolute value of 3y plus 5. And what's on the right? 2. Now is the absolute value by itself? Yes. So now you are ready to take this problem, to split it up, and solve it. Okay, so the extra step that you had to do, we did it together. Now try to do that one just like you did the last 3 problems. Look at this one. So we did the first step together, and then we split it up. 3y plus 5 equals 2. And this, what's the second equation going to be? How about Matt?
3y plus 5 equals
Yep, good job. Equals -2. And let's do the one on the left. Any adding or subtracting we need to do? Yep, and what did you subtract on both sides? Yep, so subtract 5 on both sides. We get 3y equals, what's 2 minus 5? -3. And now the last step, is there any multiplying or dividing we have to do?
You divide +3 on both sides.
So divide each side by +3. And Marie, what's -3 divided by 3?
-1.
-1. So that's our first answer. Y equals -1. And now the second one, we're going to do the same steps. So subtract 5 on both sides. Plus 5 minus 5 is 0. Eli, what does that give me on the left?
I kind of messed up on that one.
Okay, so what would you get if you just simplify what we have on the board, on the left side?
-2 divided by -5.
No, left side.
On the left side?
Yep.
3y.
Yep, so I still have the 3y. And now the right side, that's negative 2 minus 5. What's negative 2 minus 5? Give me, yeah.
-7.
Negative 7. Now the last step, same as the other problem, we're going to divide by 3, but does 3 divide into negative 7? No. So then we just leave our answer like that. Negative 7/3. So that's one that would be a little tricky to graph on the computer. Let's try to do it by hand. Okay, so here's my number line. Well, -1, that one's easy. Just put a dot on -1. And then to figure out where negative 7/3 is, we can just use the calculator and do 7/3, and it's negative. So it's negative 2.3. So where would I put my dot if I want it to be at negative 2.3?
Close to the. So right close to the -2.
To the right of the -2 or to the left?
The left.
Yeah, to the left. So negative 2.5 would be right in the middle. We're not quite that far. We're more like right about there. Okay, that's about negative 2.3.
Do we have to put the marker line?
You did say to solve, and it gave you the number line on your guided notes, right? Or it didn't? Oh, it didn't have it on your guided notes? No, that's okay then. If I had known, if I would have skipped the graph. So we'll skip the graph for the last one because it's not printed on your notes. All right, so last one. See if you can solve that. We can do the first step together. So first thing you ask yourself, is the absolute value by itself? Okay, no, so we got to fix it. What's messing it up so that it's not by itself? Yeah, that +5. So how do we get rid of a +5?
Minus like 5 or 12.
Okay, anywhere else?
And the absolute value.
And this side. So we're going to minus the 5 on both sides. And what does that give me for a new equation once I minus the 5?
X, absolute value would be x minus 1 and equals 7.
Equals 7. Yep. Okay, so now you're ready to split that up into 2 problems. Okay, let's take a look at the last one. So the first step was to get the absolute value by itself. Okay, what's the first equation that you split this one into?
That's the absolute value equals 7.
So once we split it, the absolute value is gone.
Oh, sorry, x minus 1 equals 7.
X minus 1 equals 7. And how about, Zach, do you know what my second equation would be?
The second equation will be x minus 1 equals -7.
Perfect. Okay. And on the left, Sam, how would I solve that one?
You would subtract 1 from both sides, and that would give you +8.
If you subtract 1 from 7, you wouldn't get +8. You'd get 6. So-
You're supposed to be adding.
So do we want to subtract 1 from both sides?
No, you want to add.
Yeah, we want to add 1. So we do want to get +8, but we can't do it by subtracting. We get to add. So x equals 8. All right, and add 1 on both sides. What's -7 plus 1? -6. Yep. Okay, so that's solving equations with absolute value. Okay, so the homework tonight is the worksheet on 1.4. Okay, just a reminder that progress reports close Friday for academics, and then the next week for the shop.
So we close this Friday.
For academics, this will be our last grade we get on the progress report. Yep.